we've talked about two different types of compound inequalities. We've had the or kind where it's this is true or that is true. And then we join those with that little union symbol. And then we've got the ones that are and, which is kind of like between. You know, X is between this number and that number. Now we're going to talk about the special cases of these. So an example here, we've got a sign at the ticket booth reads, guests that are under 3 years old and over 62 years old get free admission. Does it make sense? Can you actually be under 3 and over 62 at the same time? No, you cannot. So how would you do that? But these special cases, sometimes we have no solution, infinitely many solutions, which is the all real numbers. No solution, we'll put like that, or overlapping solutions where we have to see that both of them make sense at the same time. So I'm just going to do two of these, and then I'll do several on the next page for you. So this first inequality, x is less than -3, and x is greater than 7. Can that be true? It's sort of like my under 3 years old and over 62 thing that we had up above. We can't actually have both of those true at the same time. You could if it was or, but not if it's and. So this one is no solution. The next one, x is greater than or equal to 0. By the way, up here, I should have put open. I knew it wasn't going to work, so it didn't really matter, but it would have been open circles instead of closed. But x is greater than or equal to 0, and x is less than 6. So the part where it overlaps right here is the part that we need. So we would say you ignore all those other parts that are on there. You would say that x is, or a, sorry, this is an a, greater than or equal to 0. So it's going to be a bracket because it's closed. The or equal to part makes it closed. And then also less than 6. So that actually can happen. And remember, since it's less than, not less than or equal to, it's open right there. So that is this part. You would graph it a little bit more neatly than that. It would be graphed like this. And then we'll go down and look at some on the back page. So here we've got two different solutions, or two different problems that we need to come up with the solution to. So x minus 4, doing the opposite, I'm going to add 4. So I have x is greater than 3, or I'm going to divide here by -8, because that is next to x, so it means multiply. So I have x is less than, sorry, we have to flip it. When we divide by a negative, we have to change the sign to the other direction. So x greater than -6. So in this case, this is what we would call an overlapping solution. If I were just to graph those, x greater than 3, that'd be here, over to infinity, right? and x greater than -6 is here, and it overlaps that part. So I can say, since this is an OR situation, I can just graph the x greater than -6 because it includes x being greater than 3 in there. Those lines overlap. If it's and, you can't do it that way. We'd have to say x greater than 3. But since this is OR, then I can go with the x greater than -6. So it's infinity to the right, positive infinity. I'm going to start with -6 on the left part here. And then as we're moving to the right, we move to positive infinity. And infinity always has the parenthesis on the end. So now I've got and for these two. Let's solve and get r by itself. If you still don't know how to do this efficiently, you need to ask me for some more algebra practice so that you can do it quickly and easily. I know some of you are still struggling with it. And I'm going to divide by -2. Since I divide by a negative, I have r less than or equal to 1. So I've got this and situation going on. Okay, so I've got an r less than or equal to 1, and I've got r less than 3. Since this is and, though, those both have to be true. And it's not true through this part. So only the purple part is what's going to be true. So the r less than 3 is what we're looking for. Just the purple parts. So putting this in interval notation, I've got negative infinity this way because this is going towards negative infinity. It's on the left. Then I put the 1 on the right, and it is closed with this or equal to here, closed circle. So there's a bracket. This one's or. So solving each one of these, I've got a minus 4 divided by -2. Remember, I multiply by what's in the denominator, and I multiply both sides. So -2 cancels with -2. I'm left with a minus 4. Then adding 4 to both sides. Oh, hang on, because I multiplied by a negative, the same thing happens, that I flip the sign. So now I'm going to have a less than or equal to 2. And over here, I just add 1. Okay, so this is an or situation. So I've got a less than or equal to 2. This is what we did on a previous lesson when we did the or compound inequalities. So remember, this is negative infinity this way. And then I'm going to have x is also greater than or equal to 7. And this is positive infinity. So this is where, since it's or, this is a solution. So I need to write both of these. I've got negative infinity, and then we end at 2. 2 is closed. And then we put this little union sign there. And 7 is closed. So we put a bracket. And then infinity. Number 15. Now I've got a couple different steps. So x is greater than -5, or subtract 5 here. So 9x is less than or equal to 36. So x less than or equal to 4. So in this case, we've got greater than -5 and less than or equal to -4. So we have negative infinity on this side, but it doesn't stop anywhere, really. With both of these being or, we graph them on the same number line, and it actually includes all of it because it's all covered in green. So we've got negative infinity to positive infinity. We call this solution all real numbers when the number line is completely covered in whatever you just graphed. So the interval notation is simply negative infinity to positive infinity. And remember, infinity is always open. Then number 18. We solve again. And I'm dividing by 6 because it's multiplied. K is multiplied by 6. Then over here, I just subtract 5. So I've got K being less than or equal to -10, while also being greater than or equal to -7. So -10 is barely even on here. So it would be down here, and it's less than. And then K being greater than -7 or equal to is this way. You could graph this if it was an or situation, but it's not. It's and. So this one is no solution. That doesn't work because it can't be both less than or equal to -10 and greater than or equal to -7 at the same time.